Hello and welcome to the third in the series of videos aimed at developing retro games in vanilla JavaScript, using the canvas element. My name is Anthony, and please join me in my corner of the web, where I like to build stuff for the browser with the latest technologies. So, I had planned for this video to be shorter, but it quickly became apparent that this wasn't going to be the case. For that reason, you can look forward to the animation topic in the next video, or otherwise we'd be here for quite a while. It would need its own dedicated video anyway, as we'll start to animate our fighters, along with adding the standard moves for each fighter. But we're getting ahead of ourselves again. In this video, however, we'll be going to be covering ES modules, discussing what that means, and then moving to understand a little bit about object-oriented programming. Once we've refactored our code, it'll be the right place to enable us to flesh out our fighter code. But we'll first take a slight detour and discuss frame timing, just so everyone understands why this is important in game development in the browser. With that, let's pick up where we left off. In the last video, we had our main loop bouncing Ken back and forth across the canvas element. As we'll be looking to extend our code considerably over the next few videos, to proceed with just one code file would be far from efficient. So to move forward, we'll look into using modules, in preparation for what we'll be doing in the future videos. I won't get overly deep into what modules are, but if you've done any front-end development in the past few years, you've probably been using them for a while now. But for those who haven't, basically, it provides a way for front-end developers to split code over multiple files, and then reference code from those files within other files. This allows you to scale your code base more easily, whilst also providing a way to maintain your code more efficiently. Historically, modules would have been something you could only handle at build time, but thankfully we now have native support within modern browsers, in the form of a standardized format called ES modules, or ESM for short. So we get all the goodness they offer without any necessary hassle of using a bundler or build tools, if you're familiar with those things. So let's go ahead and jump into the code, starting with the HTML file. We'll hide the CSS for now, as I doubt we'll be changing it much in the remaining videos. This will obviously free up some of the screen real estate to allow us to see more of the HTML code. To enable us to use ES modules in our code, we'll first need to add the type attribute to our script tag, and then set it to module. You can also safely remove the defer attribute too, as this is no longer required, as using the module type automatically infers this by default. And it's as easy as that. We can now go ahead and split our code over multiple files. So let's start doing some refactoring, and apply our new file structure so that the code is easier to maintain. We'll start by creating two folders, one for our images and one for our code. So head over to the Explorer window and click the new folder button. We'll name the folders images and src for source. If you've been following along, you should have at least 4 files, this being index.html, index.js and our 2 images, ken.png and background.png. If so, we'll move our JavaScript file over to the src folder, and both of our image files over to the images folder. We've now obviously broken our paths within the HTML file, so let's go back and fix those before moving forward. Checking back in the browser, everything should now be working as before. Okay, great stuff. Let's now start refactoring our code over to using modules. Looking at our files we currently have, we seem to have 2 things that we draw to our canvas, our Ken sprite and our stage background. Generally, when talking about games, these things are usually called entities. An entity is an object that interacts with the game and possibly responds to either player input or other entities. If you have used other game engines before, you might know these entities as other names, such as actors or game objects. Either way, these are perfect candidates to turn into modules. Heading back to the Explorer window, I'm going to create 2 new JavaScript files within our source folder, and call them ken.js and stage.js. These files will house any code that is specific to those 2 entities. As we progress, we'll start to build a list of entities that we'll use within our game. So from our index.js file, I'm going to pull out any code that relates to our Ken entity and move it to the ken.js file, and then do the same with the stage background with the stage.js file. We'll start with Ken and take a copy of the query selector, as we'll also need some of that code in our stage file. We'll then cut the position and velocity variables, the movement logic, and lastly the draw image function. As for the stage background, we only really need the draw image, So we'll take that along with the query selector and drop them into the module file. Going back to our index file, we'll also remove all the commented code, as we'll no longer be needing any of that. Let's take a brief look at our code we've taken for our Ken entity. I think we can see some clear distinctions in the code here. We have our query selector to reference our image, our variable setup, our movement logic, and lastly our draw call. So let's first wrap these sections into their necessary functions. We'll start by fixing our query selector to just pull in the Ken image by using its alt attribute as the selector. We'll leave both the position and velocity variables where they are for now. In regards to the remaining code, I'd like to introduce a common game design pattern for our game and each of our entities. We will add two primary functions, one to contain the entity's logic for updating its state, and secondly, one to contain its drawing calls. We'll talk more about this later in the video, and it will become more obvious over the course of the video series overall. But for now, all we need to know is that it just helps to split the responsibilities of the code. So let's wrap an update function around Ken's movement code, as this is the only logic we currently have, and then continue to wrap a draw function around the draw image call. To stop any naming collisions, we'll temporarily add the word Ken to each one of these functions. More on this soon. We'll do a similar thing with the stage.js file, updating the query selector and then adding a draw function. Note, as the background currently has no logic, there's no reason to add an update function here. To complete our first set of entity modules, we need a way to make these new functions visible to other files. Luckily, this can be done with the new import and export directives, meaning that we first need to export the necessary items that we later want to import elsewhere. So let's go ahead and export all our new update and draw functions in both modules. Back in the index.js file, we can now safely import those functions we've just declared from the required module files. We'll go ahead and add them into our frame callback loop, in the same order as before. We've now hit our first problem. We no longer have access to any of the variables declared in our index file from the other modules, primarily the context. Let's fix this by passing its reference into each one of the new functions. In the Ken module, the references we have to the game viewport enum will also need to be updated. In the update function, we can safely swap to use the canvas's element property that the context provides instead. However, we don't have that luxury for our position x variable, so we'll just replace it with a hard-coded random value for now. 80 seems like a good value to me. Not forgetting to add the context reference in the stage module too. So if everything has gone to plan and we haven't broken anything, when checking the browser, we can celebrate with joy knowing absolutely nothing has changed. Great, huh? Although to be fair, the actual benefit here is that we can now work more efficiently knowing we've abstracted our code to use modules. As we now have modules hopefully working correctly, I think it's time to give Ken a friend. Heading back to Spriter's resource again, we'll do exactly like we did in our previous video, and bring in another fighter into our code. I'm going to copy Ryu's sprite sheet this time around, but again, you can choose any fighter you prefer. Either way, crop down to their main stand sprite, and save a copy of it as a PNG file in your new images folder, not forgetting to enable transparency for the blue background. With Ryu's image now in the images folder, let's go ahead and add a new module for him. But first, just like the previous video, we'll need to add an image tag for our new Ryu image to the HTML body with an alt attribute. In regards to the module, to save some time, we'll just make a copy of Ken's module file and reuse it for Ryu's module, naming it ryu.js. Once created, let's go into that file and correct any references from Ken to Ryu. Just for fun, we'll set the velocity to -1 to add some variation. Back in the index.js file, we'll import Ryu's update and draw functions and then add them into the frame callback loop alongside Ken's. Checking back in the browser again, we should now have both Ken and Ryu bouncing back and forth across the screen. Hopefully, with our three entities now split over multiple files, you can see how easier it is to manage our code moving forward. The other thing you may have noticed is that we now have some repetition between the Ken and Ryu entities. If we were to add more characters to the code, you could probably see we would be repeating ourselves quite regularly. Let's look to solve this with some object-oriented programming, and one of its key features, inheritance. So what is object-oriented programming, or OOP for short? Well, it's a style of programming to encapsulate data, functions, and properties into objects, usually in the form of classes. I'm sure some of you will be thinking that we've just done something similar with our new modules, and you'd be correct in thinking that. However, with classes we do gain several features, primarily the ability to instantiate new instances of objects and inherit and extend them. Also, the class structure can arguably make your code easier to read, and is generally the more common way to write your code in the OOP style. I won't bother going over the usual JavaScript doesn't really have classes topic, as I'm sure everyone knows that by now. But from this point on though, we'll continue to use classes where we need to create instances of our entities, although the majority of what we do here can be done with object prototype chaining, if you prefer that method. So with that, let's have a look at both our Ken and Ryu entities, and briefly try to understand how OOP helps us with inheritance, and why that even matters at all. Firstly, let's take a step back as we need to understand the relationship between these two entities. Starting with our Ken module and its code that we've just refactored, let's list the properties and functions it currently has. In regards to properties, we know we have its current X and Y position, its movement speed, and its image data. We also have the update and draw function calls. We also know that Ryu has the exact same base structure. In fact, if we were to add any of the original 8 selectable characters, they would all probably follow the exact same pattern and structure. Now I know this list is not exhaustive, and will definitely change in the coming videos, but when we have repeatable entries like this in our entity structure, it would be better for us to move these common entries further up the chain into a base or superclass. Our Ken and Ryu entities could then use inheritance and use these base entries from that class. I'm going to call this superclass Fighter, as it would make sense to move these common entries to that instead. We can then just inherit these entries from within our Ken and Ryu classes. These classes could then just have properties or functions specific to those fighters. For example, we could have a standard set of moves in the Fighter class that all fighters have access to, but these could be extended in the Ryu and Ken classes by having specific special moves that only they have access to. Hopefully this gives you a brief understanding of what inheritance is, but how do we do this in JavaScript, I hear you ask? Well, let's go back to our code and add a new JS file in our source folder called Fighter. In there, we'll create a new Fighter class to house our common entries as we just mentioned. We'll add a constructor function first and then add its common properties. A constructor is a special class function that is called every time a new instance of an object is created, so it's a perfect place to add any initial variable values, or the object's default state. We should also probably mention that any references to entries within a class need to be prefixed with the this keyword. The this keyword could have a video entirely of its own, so it will be a discussion topic for another day, but for now, just know that it's generally used to tell JavaScript that we are referencing properties within this class, at least in the scope of this video. Let's start by adding the known properties this class needs, while leaving them undefined for now. We'll also add an extra variable called name, just for identifying purposes. As the constructor is called when a new fighter object is created, we can pass in some initial default values for our properties. We'll start with the obvious X and Y positions, but we'll also pass in the name. For now, we'll also add the velocity too for completeness. Let's finish our initial structure of the class by also adding the update and draw functions. We know from our previous refactoring that we'll also need to pass in the context into both of these functions. We'll now again go and move our function code into the base fighter class, not forgetting that we need to now prefix the properties with the this keyword. As within the superclass, we no longer have a specific fighter image property to hold our image data, so you may have noticed we're using the generic property name image instead. Let's do the same with our draw function too, moving over any code and updating any references. The final step is to now transfer our constructor values over to our class properties. As the image property is specific to each fighter, we'll be defining it in each of their specific classes, so we'll just assign it to a new image object for now, as it's generally good practice to give all your class properties a default value if possible. And with that, we now have our fighter class fully defined. However, for us to inherit this class, we'll need to refer to our previous knowledge about modules and export it. Okay, moving on to our specific fighters, let's go ahead and convert those over to classes too. I'll start with Ken and wrap his code in an exported class. To inherit from our fighter class, we'll use the class extend keyword. As mentioned, this will give us access to any of that class's entries, but will be scoped to this class. To ensure we're able to reference the fighter class here, we'll also need to import this reference. Thankfully, VS Code is smart enough to do this for us, as long as we use the IntelliSense dropdown. Although it may still seem to forget to add the JS extension at times, so we'll go ahead and correct that before continuing. Just like before, we'll start by adding the constructor function. Again, we'll need to use the arguments for the default values. but notice I've missed the name argument this time. This is because we'll be setting that here in this class. As we're inheriting from the fighter class, we must make a call to its constructor, as this would fail its inheritance relationship otherwise. We do this with the constructor's super function, which, as you can expect, basically calls the constructor function in the inherited class, which for us is the fighter class. We'll use Ken for the name parameter, but just forward on the other arguments. We'll next move the query selector into our constructor and change it to use our image property instead. In regards to the update and draw functions, we can safely just delete that code, as the fighter class now has that responsibility and code. In regards to our position and velocity variables, these will be set via our class constructor functions, so we can again safely delete this code too. So let's do the same refactoring with the Ryu module file as well. For ease, I'll copy the contents of the Ken class from the Ken file over to the Ryu one, and update any necessary references. If we were to compare the classes now, you can see that the fighter class now takes most of the brunt for our code, leaving the Ken and Ryu classes very clean and are now currently just using the builder pattern to instantiate the fighter class. Jumping back to our index file, we'll first update and fix our input references, and then create new instances of our classes above our frame function. In regards to the constructor arguments, we'll pass in the default values we had before for our position and velocity variables. And finally, we'll use these new Ken and Ryu objects to update the references in the frame function itself. Okay, for consistency and to complete the refactoring, we'll also convert the stage module over to user class too. Just like our Ken and Ryu classes, we'll add a constructor and move the query selector over to it. As we're not inheriting any base class here, at least not yet, we'll just add its own draw function, passing in the context. Lastly, we'll remove the previous export draw call and fix the image property reference. As before, in the index file, we'll also update the import, create a new stage object, and then update the reference in the frame function. After all that refactoring, let's just again check the browser and see if we've broken anything. And great, nothing has changed, which is exactly what we wanted. Another practice I like to implement when using classes is a naming convention for my module files. I prefer to start the file name with a capital letter, just to infer that these files are classes, and not regular functions or helper modules. This is just my personal preference obviously, so you can easily skip this step if you prefer. If you wish to follow my practices however, let's head over to the Explorer sidebar once again and rename our entity files. Just to keep our house in order, I'm also going to create a folder within our src folder, and call it entities. Within that folder, I'll also create another folder called fighters. With those created, I'll move our fighter, Ken and Ryu files into the fighters folder, and then move the stage file into the entities folder. As these changes affect our file locations, we'll need to update our input paths too, so that they match. VS Code might actually help you here and realise that the files have changed, and update any input paths automatically. Either way, just double check the paths and save any changes. So to finish today's video, I'd like to talk a little about frame timing and why this is important to game development, especially browser games that cater for multiple platforms and hardware. As you saw in the previous video, I have a high refresh rate monitor running at 160Hz, which the browser was happily keeping up with. That's not me boasting however, but rather to note that this is quite an unusual refresh rate. The most common refresh rate these days is 60 or even 120Hz, but then there's potential for some people out there with even higher refresh rates. But that's not all. Our users could be running the game on anything from low-powered mobile phones to high-end gaming PCs, or anywhere in between. Now consider the original Street Fighter 2 game. This ran on dedicated hardware called a CPS, or CPS system, and it ran exclusively at 60 FPS, as did most retro games at the time, so we know this was updating the screen 60 times a second. Luckily for the original developers, they didn't need to cater for anything other than that hardware, so rightly or wrongly, they specifically targeted this internally for their timing purposes, so all animations, movements and fighting moves were tied to it. This is now considered bad practice, especially when you're catering for multiple platforms and hardware. So unfortunately, as web developers, we can't do this either, as we also don't know the target platform or hardware, only our personal testing machine. So let's take my display refresh rate as an example. Comparing it to the original game, we now know our code is running too fast, as we're getting 100 frames more than is required each frame. And as you can see here, comparing the current code running on a display that is 60Hz versus my 160Hz display, you can instantly notice the speed difference. As you can guess, this is not so great. You might have already seen evidence of this yourself if you have ever played an old game on your current PC, and it turns out it's running too fast if you turn VSync off. This is because again, the game speed is tied to the frame rate. So how do we make our game run correctly and hopefully smoothly on everyone's machines? Knowing we shouldn't fix our game updates to frames, we should rather look to base them on time instead. As we know time is constant, we are no longer dependent on either FPS or hardware. Let's go back to our main frame function and see what we can do. One of the things we haven't mentioned yet is that the request animation frame automatically passes in the current game time into its callback function. This special time counter is unique to this instance and is measured in milliseconds, starting from the first time we call the request animation frame function. With any subsequent calls, the latest tick will be passed in. Let's test this by adding the time argument into our frame callback function, and then log the value out to the console. As you can see, the value is constantly increasing with each frame call. With this time value, we can now calculate how much time has passed between each frame. We'll add a previous time variable to store this frame's value, and then add a seconds passed variable to hold the calculated seconds between each frame. We do this by subtracting the value of the previous frame from the current frame's value. To get the value in seconds, we also need to divide the result by 1000, as the time is stored in milliseconds. We'll then store the current time value in our previous time variable. Now that we have this seconds passed value, we can pass it to any entity that requires updating between each frame. Currently this is only our Ken and Ryu entities, as the stage background is static. We'll first add the value to both of their update arguments here, and then go into the fighter class and mirror the parameter list on its update function. For this to work as intended, we'll need to multiply our velocity variable with this new time value. Before explaining what we've just done, let's quickly look in the browser to see how these changes have affected our fighter's movement. So, Ken and Ryu seem to be moving at a snail's pace, but to be fair, this is to be expected, as their velocity only has a value of 1. As we're moving based on time now, this basically means we're moving 1 pixel every second, rather than 1 pixel every frame. While we're here, the other thing you may have noticed is that the images become blurred between each pixel movement. This is a side effect of the draw image function with how it works with decimal values. We'll look to correct and explain this in the next video, but for now, let's ignore it and fix Ken and Ryu's movement speed. We simply now need to increase the velocity speed to a more suitable value. I'll use a value of 150 for now, so that they move 150 pixels per second. Quickly checking in the browser this time around shows that it's quite well. Just to help with comparisons, let's create an FPS counter, and rather than logging into the console, we'll use our canvas as context instead. Following what we did before, we'll add a new file in the entities folder called FPS counter, creating an exported class with a constructor, an update and draw functions. Inside the constructor function, we'll add a property called FPS to store the current FPS value. In the update function, we'll pass in the seconds passed value and store the value to our FPS property. We'll wrap the value in a trunk just to remove any decimal values. In our draw function, we'll again add the context parameter, and in the body we'll now use some new functions to draw text to the canvas. To do this, we'll first need to set the font. I'm using Arial with a height of 20 pixels and a style of bold. To set the colour, we'll use the fill style property, where I'm setting it to black. You also have the option to set the alignment. I think it's best to use centre here. Just as a side comment, you'll notice the files we're using are very similar to that of CCS. Then, to draw the actual text, we'll use the fill text function, where we give it the required string we want to write. We'll use the string list rule and pass in the local FPS property. Just like the draw image function, we'll also pass in the required X and Y positions. I've set it near the top of the screen on the Y position, and then centered it on the X position using the canvas's width property. And with that, we should be done with this small entity module. So instead of following what we've done previously, let's take a step back for a moment. Unfortunately, you may have also noticed we've started to get a little bit of repetition forming with our entity list. They all have an update and draw function, and we're calling them individually in our frame function. As we know all of our entities have this contract, it would probably be better to add them to an array and loop through them all instead, although we do have one minor exception here. and that is with the stage class. At the time, we purposely didn't add an update function, for this not to cause an undefined error. Let's go ahead and add a stub update function for now, as we'll definitely be using this in the future video. Back in our index file, we'll first import our new FPS counter, and then wrap our constructor calls in a new variable array called entities, adding our FPS counter at the bottom. Do note that the order in which we have these are important, as this will be the order in which they are updated and drawn in our main frame loop. And inside this function, we'll remove our entity update and draw calls and replace them with a for loop instead. One for loop for the update function and then another for the draw function. It's best to keep these calls in batches, rather than together, to help with the frame consistency. And with that, we now should be good to have another look in the browser. And for the last time, everything looks as it should. Our FPS counter is correctly showing our current frame rate and the amount of calls per second. Also, both Ken and Ryu are moving correctly based on time rather than the frame rate now. We can easily prove this again by running the same code now on a 60Hz refresh rate display. And the results this time are identical. Perfect. And to complete our refactoring session and today's video, we'll quickly make a couple of minor tweaks to our index file. Until now, we've had our request animation frame call at the bottom of our frame function. We'll move it to the top as this is considered best practice, because the sooner we can request a frame from the browser, the sooner it can respond. And lastly, we'll also change the onload function handler over to an event listener. Even though it works in exactly the same way as the current onload property, I personally think this is cleaner and honestly, it's a little friendlier on the eyes. And that is where I think we'll call it for this video. I'll quickly list what we've achieved today. Yes, so it's been quite a technical video this time around. I appreciate the game has not really moved forward too much in this video, so it might not be everyone's cup of tea, but hopefully, some of this information in the video did help someone. We're definitely in a good place now to start building the actual game though. As mentioned, the next video will be on animation, which in itself is quite a large subject. We'll also hopefully start to bring in the basic moves for our fighters too. So yeah, we'll see how long that video turns out to be. This will feed nicely into part 5 of the series, where we'll discover how to implement input devices such as keyboard and joystick controls. So plenty to get on with. Again, if you've made it this far, I thank you, as I really do appreciate you taking the time to watch this content. If you like what I do, or even if you don't, I'd love to hear your thoughts in the comments section. Also, if you've yet to subscribe, why not do that too, just to help me grow the channel, and if nothing more, to let me know that you'd like me to continue the series. Okay, we're done. I'll see you in the next one, I guess. Ants out.